Okay, so here's where we were the other day. We started out by saying, let's go find the worst motor. And the way we found the worst motor originally was we did the work of trying to figure out what worst meant for motors. And so we were the ones that talked to each of the motors and dug out, in this case, how much time had been used on the motor. And then we were the ones that tried to figure out what better meant from those two integers. We fixed that version to add in this line and say, well, instead of us doing the work of figuring out what makes one motor better than the other, why don't we let the motors figure it out? So what we did is we took one motor and we introduced it to another motor, and we said, here, you tell me whether you're better or worse than the other guy. Okay? So now we don't have to worry about what better or worse is. We just listen to whoever we're talking to, and they tell us between those two people who was better. Okay? And if we go look at motors compare to, motor is the one that hides the work of saying, well, I think the thing that makes one motor better or worse than the other is the amount of hours of service. Okay? And so compare to now became this general idea that regardless of the type of thing you have, whether it be motors or students or any other class that you build, that if we write a compare to, then all of a sudden the code that we wrote at the level above doesn't need to care anymore about the details of what's the next level down. Okay? It just becomes generic code. And so the rule now becomes, when you're writing your class, it's a good idea that you think of a reason why something would be better or worse than another. And usually that relates to the kind of problem that you're doing. So for instance, like I said, if we write a student class, then we say, well, okay, for the most part, we want to compare students by GPA, if that's some value that we've got recorded. So we'll automatically write a compare to that works against GPA. Okay? If the way that your problem normally dealt with students was to put them in alphabetical order, then your compare to would worry about which last names came before which other last names in order to put students in order of last name. Okay? So you get to write one compare to inside your object that best describes the kind of comparison you're interested in dealing with for whatever this thing is probably going to be used for. Since compare to is now something that everybody should do, it becomes essentially a standard that says, okay, if there's one in here, I know that there's a way of putting these objects in order. What you do at the top of the file is you say implements comparable for that thing, and that's just a flag, a sign that you put on the front of the door that says, hey, if you want to sort these things or put them in order, this thing automatically has a way of doing it for you, whatever that happens to be. Okay? And then, since that thing is now a standard, it means that there's some standard routines that can work on it. So there's this collections library that has collections.max, find me the biggest one, and it does its work. You just say, here's the list of things, and it's got pretty much exactly this code inside of it that's now generic that will go and find the biggest of anything. It's exactly the code we wrote, more or less. Okay, just plopped into a function or a method. Okay, so they've made standards for all of those. So there's collections.max, there's collections.min to find the smallest. Sorting is really just doing find me the smallest over and over and over again, if you want to think of it that way. Okay. And reverse is what you use to flip the list around, so you get it in one order, smallest to largest. If you want it the other way around, you just flip the list around after you've got it sorted and it's in the other order. Okay, so that's what we did the other day, and then we said, well, okay, what if you're searching for an item? So we started out the same process in searching for an item and said, well, typically the way that somebody would search for something, say by serial number, is to decide, well, here's the serial number that I'm interested in, and then write a loop that goes through all of the things that you've got, trying to find the matching one. So what we'll do to find the matching one is we'll take whatever motor we get, we'll dig out its serial number by asking it, and then we'll do the comparison to see whether or not the serial numbers match. Okay? So this is okay, but it's another case of the main program doing all of the work of saying, well, I think the way that motors should be matched is by serial number. I'm going to go and dig out the serial number from underneath, and I'm going to do all the matching. Okay? And so we said that being lazy people, we would rather not do that much work, so we had to find another technique to try and figure out how to do the searching without doing so much work. And the trick to the game is to provide essentially a sample that says, here's one that looks like the one I want, and then hand that sample along and let the sample do the work of deciding whether or not it matches the one that you actually want. And so that was that business of saying, well, okay, if we're searching for hockey players, we'll dress up the little 12-year-old or 6-year-old in the same uniform as Luongo, and then we'll take him into the dressing room and say, okay, do you match this guy? And let him answer the question, yes or no. Okay? And in that case, I'm no longer worried about what constitutes a match. I figure that that fake hockey player has got enough brains to figure out what a match is for hockey players. I don't have to worry about it. Okay? So we're going to play the same trick here. Instead of making a serial number to search for, what we're going to do is we're going to play the game of saying, well, what I'm going to do is I'm going to try to find a motor that looks like this. A motor with serial number B. And here's the interesting thing. I really don't care how many maximum hours it has. Okay? If it were a real motor, like we'd created up above, when it came from the manufacturer, it would have a maximum number of hours on it. But in this case, the only thing that we're interested in creating a motor is a motor that has a matching serial number. Okay? So this thing, motor defined, is one way of referring to it. I quite often call it something like fake motor, because it's like that 12-year-old, right? It looks like the one you want, but it's obviously not the one you want because it doesn't have any hours on it at all for maximum. It's never been used before. It's obviously not a complete motor. Okay? So we'll make a motor that looks like the one we want, and then we'll play the same game of saying, let's go through all of the motors. And this time, what we'll do, instead of this code here of digging out the serial number, we'll just say if the fake motor dot, there's a couple of words we could use here. It matches. How about looks like, is similar to. Okay, I'm going to stick with looks like here. Looks like some motor then we'll say found motor equals some motor. We'll make another variable to keep track of it, and then we'll do our break again. And I'm just going to make another variable here, motor, found motor equals nothing to start with. Okay? So I made a fake motor that looked like the one I wanted to find. I made a variable that was going to keep track of basically found or not found, the actual motor. And then I go through all of the motors, and I take the fake motor and introduce it to each one of the motors, the other motors in turn that's on the list, and ask the fake one, hey, do you match the one that's on the list? Okay, so that means that in our motor class, we have to have something called looks like. So let's just go up here and let's write public Boolean looks like motor another. And now it becomes the problem for the motor to decide what makes me look like another motor. So usual way to start these out is to say, well, I don't think in most cases there will be a match. And then write the special case that says if, let's just get the other guy's serial number here. So we'll get another dot serial number. And then we'll say if my serial number is the same as other serial, then say they match. Okay, so I notice I wrote that in the rejection style. The normal case is that things don't match, and then every once in a while, if we're lucky, we say, oh, okay, it looks like the serial numbers between the two things are the same, so it must be a match. Okay, and we'll save that, and we'll go back into the driver, and we'll print out found motor. And we'll just run it and see what we get. Just be the last thing on the list. Maybe I'll put in something, some words there. See it? Someplace here. There we go. There's reasons why I like a larger screen. Okay, so notice that even though the fake motor had no information inside it, the one that we found has all of the correct information because it was the one that was on the list.
So by putting the 0 in, if there were 5 or 6 B motors with different sets of hours, they would all pop up.
But there won't be 5 or 6 different B motors. There will just be one because it's supposed to be unique, right? Okay, so this is, I mean, this is literally the same process as the physical process I described with forms, where I said when you first register, you've got a registration form that's got everything filled out. And then if you want somebody to go find that form, what you do is you give them a form with only your first name and last name in it, and you say, here, go find a matching one. And they do exactly the same thing. They take the matching one and they use it against the original, go through all of the originals until they find one with the first name and the last name, and they say that's the one. Okay, so the second form that you send in to do the searching is never complete. So it's always missing information because it's always just a looks like, it's always just a partial portion of the thing that you want, but enough to find a match. Okay, so this is actually a good clue for people when you're doing the search. If you use something, if you search for one and it's missing some information, then that's a good clue that that's not the one that you're actually trying to find or use the information from. Okay, and the joy of this thing is we no longer care how motors compare themselves. Okay. It's gone. So, I mean, think of the hockey player example again, right? I mean, hockey players, you know, you've got the jersey and you send the kid in with the jersey. You don't have to care whether he matches by the name on the jersey, by the color of the jersey, by the logo, by all of the things that would say this is a match. All that you care about is that eventually the kid comes along and says, yeah, that's the guy there. That's the one I'm supposed to match. Okay? And this is a very, very common technique of saying, I want to hide that information at my level, I don't care. Let the person below deal with it. Not my business. Okay? And in the long run, it's a good idea because motors know how best to compare themselves or put themselves in order from better to worst than you could possibly do as a non-expert, as a non-motor. So it's like, let the thing that knows best figure out how to do the work, in what way. Okay? So you all clear on that little technique? Because now I'm about to turn it into the real Java thing. Okay, so the name of the game here is to have something called looks like, and the looks like method is the thing that's in charge of deciding whether or not there's a match. So we could call it looks like, is a match for, is similar to, all of those words that say it's not the original but it's darn close. Okay. The problem with Java is that Java says this is a good idea, but the word that they use is not looks like. The word that they use is equals. Okay? Now this sort of gets really silly because now we've got single equals for assignment, we've got double equals to say these things are exactly equal, and we've now got the word equals, which also means equals only in the sense of is similar to. So mostly equal, but not quite. Okay? So to me, it's the worst possible choice of word. Why didn't they use a word like matches? Because matches typically in the computer science world has always involved something with string comparison, and this isn't necessarily string comparison. Okay? So matches would have been the word I would have used, but it was already taken. I would have preferred is similar to, looks like, but you're stuck with this. So you got to learn to read it as being, yeah, close enough, looks like. Okay, so once you've got that down, we're just going to go back and we're going to change this driver to now use the word equals. Same code. Okay, well, for as much as this code to find the minimum and maximum is already in a library, guess what? The code that will search for things for you is already in the library because this is just a repetitive loop that basically always looks the same regardless of the thing you're searching for. So given that you've written that, if you want to search for something, you can now use, where are we? All motors dot index of fake motor. So this is, index of is again a really, really bad name. It's really search for a matching one. And equals is looks like. So search for a matching one that looks like this one would be the better words. And what it gives back to you, just to be difficult, is not the actual motor, but where it is on the list, which is again a little bit silly, because you would sort of expect to get back, if you're searching for something, you'd expect somebody to come back and say, well, here's the thing you were looking for. What it does is it says, oh, I found you were looking, the thing you were looking for, it's at position 8 on the list.
So So then you gotta turn around and go and get it.
Then you got to turn around and go and get it. So the very next thing you do is you say motor, I used found motor already, I guess I can use found motor again. Found motor. Do it differently, I'll use a different variable. The one I want is talk to all motors again and say all motors dot get the one from that position on the list. So it's a two-stage process.
Any idea the reasoning behind it?
The question was, any idea of the reasoning behind it? And it's like, no, they were just silly. And sometimes you'll see this thing where you do a get. Some libraries will have the, oh, I'll just give you back the one that you want. In this case, this list class, so this is actually ArrayList that has that facility. Whoever wrote the library just said, no, it's always a two-stage process.
Oh,
It's just, to me, it's just sort of pure silliness, but that's the way it's done. So these two almost always go together.
On top there, when you have equals, you had before like, or is like or something. You create on Java another thing called is like. What happened with that then?
I changed the name in both sides of it.
Oh, okay.
Okay.
Good.
So both in the motor class
Right.
and the call, so it's the same.
Okay.
Yeah. Okay. And so then you can just print out the one that you want. As that variable. And you'll see that this thing does almost exactly the same thing, except it died. Oh, that's okay. Why did it die?
Tried to access an array position that doesn't exist.
Tried to access an array position that doesn't exist. Notice the position that doesn't exist is -1. And notice the last thing that we recognize is our driver code got to this line and it sent in a -1 to try to retrieve something. Okay, what do you think the -1 means? Where do you think it came from the line before?
Because you put fake motor instead of found motor.
Nope, we're searching, we always search for the fake. So that's fine. So -1 is a position that's not on the list. So the -1 is saying, you asked me to search for one that matches, and I didn't find a matching one. Okay, so why wouldn't it find a matching one? Because it looks like it was searching for one. Well, okay. Let's just comment out our code here, just so that it doesn't get in the way of the real one. And then what I'm going to do is I'm going to put a breakpoint in our equals method so that I can see it being used. And we'll run with the debugger. And that was an old compare2 breakpoint that we don't care about. We're looking for equals, and this is it stopped, it put a breakpoint in ArrayList, something we don't own, because it's about to die. Okay, so the bottom line is it never used our equals. Because if it used our equals, we would have seen it stop there. Why didn't it use our equals? Well, this is a little Java trick. That's the way you would think to write it, because that's the way that we wrote compare to, right? We said compare to will compare against another motor. It turns out that equals has a glitch. Because technically speaking, it's okay to see whether or not a dog equals a cat, and the answer is, of course not. Okay? So equals is actually allowed to compare things that aren't motors against motors, and then the answer is, well, if it's not another motor, then they can't possibly be the same thing. Okay? And that would be the most general form of equals that you could have. Okay? So the guys who designed this said, oh, well, okay, we'll make the most general form possible. The problem with that is that the general form is something that you pretty much never ever want to do, because it wouldn't make sense to compare two completely separate things. If you're comparing two things that aren't at all alike, chances are good that you've probably messed up in your program somehow, and it's very unlikely that you actually wanted to do that. So in my view, this should be correct, and if you do anything else, things should die. But in the Java library view of things, the thing that goes here is the word for any old thing, which in Java terminology is an object. So big O object is just like anything. Okay? But what you actually have is a motor, so I'm just going to change this to what? And I'm going to play this little trick. To fix it. And what that does is that says, you gave me something that could be anything to try to do the match against. This line here says, I don't care what you say, this thing had better be a motor. Okay? It's a motor, damn it, put it into a motor variable for me. Okay? Now, what will happen is 99% of the time, if your code is written correctly, that will be okay. If you ever try to send the wrong type of thing in, like a cat, then when you try to say, I want a cat to be a motor, it's going to die, and it's going to say, can't possibly be a motor, and your program will die there when it tries to do the conversion. So you can't turn a cat into a motor, it's just impossible. Okay? But you have to put those two lines in because this is the official words that have to be used. Okay? So your equals method is almost always going to be written like this with those two lines. You say equals this line exactly, and then the very next line, if you're in a motor class, you do this game with motor. If you're in a student class, you put student on either side, and you just basically repeat that line. And that says, put it into the kind of variable that I want.
So you're forcing the object.
You're forcing it to you're basically identifying it.
Yeah.
So this isn't really sort of forcing it to be anything. It's really just identifying it as being something so that now you can talk to it in the appropriate way. Okay? So it's no different than right now you're all people, but I can turn around and put on my parentheses hat and say, oh, I think you're a student, and now I can ask you student questions because I know that you're a student. Okay? What classes are you taking now becomes something appropriate to ask students. So they start out as generic things, could be anything, but this is, I know what you are, and now that I know what you are, it's reasonable to ask you kinds of things that are words that you're familiar with. Okay? I've still got the breakpoint there, so we'll save that thing, and we'll now turn around and run with the debugger. And now it stops on equals because now it has the correct format. Okay? And so now if we just let this thing run, I'm just going to kill it off and I'm going to run it in the normal way. If we let it run, there's the found another. Okay? Now, same sort of thing as compare to. If you spell this wrong, it's just some arbitrary function that could be anything, and that's perfectly fine. Okay? Except it's not the standard, right? So we'll use that same thing we did over top of compare to, and we'll say at override to say this thing I want to be like the standard one. And as soon as you make it say I want it to be the standard one, now all of a sudden you'll get the error message that says, well, no, that's not what the standard one looks like. And the standard one has to have that in it in order for it to work. So that's a good way to prevent errors on those two things, on those two standard ones, is to put at override on the top, and then you'll get the right thing done. Okay? So there's our matching one. So index of is find a match for, find one that looks like, and the equals method is does this match, is it similar enough to, does it look like the one I want? Okay? So this is a case where they made really, really silly wording as far as I'm concerned, and every time I have to explain this to students, it's like, oh, this is a real chore. If they'd just given it proper names, it would have made a lot more sense. So even the big guys make a mistake in their naming. And now I have to find 3 different words for equals when I'm talking to you. So equals assignment statement, equals double equals, equals the word, meaning find a match for, and I have to explain myself every time I want to use any of those 3 concepts. Because if I just say equals, who knows? Okay? So there's find a match for. So now the question becomes, well, you've actually seen what happens if you don't write one. What do you think now if I say this? I'll just put it in here. The other version of equals. If fake motor double equals found motor. What do you think that thing does? It's obviously asking whether or not they're the same. What does same mean? Completely the same as in identical. Okay? So double equals really, since you're now assembly language people, says, do they have the same memory address? Meaning they are exactly the same object because they inhabit the same portion of memory. Okay? They're absolutely identical. Okay? And what we're doing when we write this equals method is the default one, the default equals that's already there in any object, uses identical. And so when we're overriding this version of equals by writing our own, we're writing one that relaxes this restriction that says they don't have to be identical, they just have to be similar. Okay? So this one hides the one that's there, which really does that. Okay? And we're relaxing the restriction. Okay? You know, the difference between the two, another way of thinking about it is, although I guess it's bad that I used serial numbers in this example, but it's the difference between going to somebody and saying, you know, going to a warehouse and asking them to store your iPod or your phone, right? And when you say search for it, the question is, are they going to come back with a phone that looks like your phone, or were they going to come back with a phone that's identical by serial number to the phone that you actually gave them? Right? So there's the subtle difference. Identical versus looks enough like. Okay? This one is a replacement one, or one that's similar enough that I found the real one. Okay, so now we got that all set. The most common mistake that people make is that they forget to override the default one, and then when you go searching for one, you don't find it. It's like, well, hey, I put that thing on the list. It's obviously got to be someplace, but every time I call index up to search for it, it never finds it. Well, it doesn't find it because it's not identical, right? It's the fake one. Okay? The converse is also true. Let me ask the question this way. Instead of fake motor there, would I ever do this? I think I called it motor B. What's the second motor on the list? Oh, B motor. Would I ever, B motor is the one that I made originally, and then I put it on the list. So the question is that a reasonable thing to do?
No,
Because
it's not annoying.
it's not what?
It's
It's not a
outside the
list.
list.
It's just one,
Isn't that a lot of
it's
this?
one variable.
It's already on the list,
Yeah,
because I used B motor to put the thing on, to add it to the list originally. Would you ever want to use B motor to search for B motor on the list?
no,
Because
it's B
Because it
motor.
doesn't have a position on the list.
because you already got it in hand, right? Like, I've got the thing I'm looking for. Why would I ever search a list to find the thing that I've already got in hand? I'm already talking to Roberto Luongo. Why would I bother searching through the dressing room to find him when I've already got him right here and I can talk to him? Doesn't make sense, usually. We'll find some reasons why maybe it does make sense, but in the normal case, this is probably not the thing that you were intending to do. So when you're searching for something, this is usually going to be the fake one that's used for searching, which is why you'll see me always, when I make that fake one, I try to use a word that gives the sense of it's not the real one, to try to emphasize the point. Okay, almost done. Let's just go down my list of goodies here. Yes, the special access rule. This is a good one to end on. It turns out that particularly in the case of compare to, but also equals, those routines get used an awful lot. Okay? If I'm searching through a list of 100,000 things looking for the matching one, equals, if I don't find the thing, is going to be called about 100,000 times. Okay? So equals needs to be fairly efficient. Compare to is even worse. If I'm trying to put things in order, I go through the list once, calling compare to on every item to find the smallest, and then I dig out another one and go through what's left on the list to try to find the next smallest. And so that's, in worst case, an n squared comparison. Okay, I'm calling compare to n squared times. If I've got 100 things on my list and I'm trying to put them in order, I'm calling compare to 100 times 100 times. Okay, so I've said over and over again, we're sort of not concerned about CPU cycles and efficiency, but the Java guys were for this special case because it gets used so often. And so when you write the motor thing here, having to talk to the other guy and get his serial number is a bit annoying all the time. There's what I call the professional courtesy rule here. It's like, hey, I'm a motor, you're a motor, we're using the same set of rules, I know all of the rules that you know. Let me just look over on your desk and look at something. I shouldn't have to ask you because we're going to treat each other right. Okay? Professional courtesy rule. The other way that you can think of it in Java terms, and just to be a little rude here, think of it as things that are of the same type can look at each other's private parts. Okay? So even though this variable is marked as private, because I'm dealing with another motor here on the equals method, I don't have to ask them for their serial number. I can just change this and say another dot serial number. Okay? And so notice if I tried to do this from the driver program, it wouldn't be allowed because serial number is marked private for motors. But because I'm the same type of thing, I don't have to say get serial number here. And all it does is it saves the cost of an extra method. It's just instead of asking, I can just go, oh, thank you very much, got that information, and continue on my way. And that makes it just that little bit faster. Okay, so the same thing applies to compare to. Here, you don't have to say get hours of service. You can just say another dot hours of service. And notice that it's actually given as an option by Eclipse, because Eclipse knows to say, well, okay, since you're the same type of variable, you can just use the other guy's variable to go grab the information. Okay, so there's the professional courtesy rule. And this is the way that you'll normally see it written. They won't bother with the gets. They'll just access those fields directly. Still works exactly the same way, just a touch faster. And with that, we're out of here.